A warm welcome to you all to the introductory lecture on spectroscopy. I am Dr. Manoj, Assistant Professor at the Research and PG Department of Chemistry, St. Joseph's College, Iringalappada. This session discusses the basic principles of spectroscopy. Spectroscopy is an important tool in scientific researches, especially in chemical science. So if you want to analyze a molecule or a compound, this tool helps you a lot to get the complete picture of an unknown sample. Before we come to know what is spectroscopy, it is important to know about electromagnetic radiation. An electromagnetic radiation refers to the waves of the electromagnetic field propagating through space, carrying electromagnetic radiant energy. So in this picture, you can see this is an electromagnetic wave representation. So an electromagnetic wave is formed when an electric field shown in red arrows couples with a magnetic field shown in blue arrows, which are perpendicular. So the magnetic and electric fields of an electromagnetic waves are perpendicular to each other and to the direction of the wave. So the distance between two consecutive crests, we call it as crest, and the bottom one we call it as trough. So distance between two consecutive crests or consecutive troughs is known as the wavelength of an electromagnetic radiation. So we know the Planck's radiation law, which states that energy E equal to Planck's constant h into nu, where nu is the frequency of radiation. It can also be expressed as h into c by lambda, where c by lambda stands for the frequency nu, where lambda is the wavelength of an electromagnetic radiation, and 1 by lambda is the wave number nu bar. So these are the different ways of expressing energy of an electromagnetic radiation. So we can write energy E of an electromagnetic radiation as h into c nu bar. So we are replacing nu, the frequency, with the wave number, and c is the velocity of the light. So this represents an electromagnetic spectrum. So a spectrum is an arrangement of something based on the increasing or decreasing order of any of its properties. For example, if you arrange electromagnetic radiations based on their increasing order of wavelength or decreasing order of frequency, so that arrangement is known as electromagnetic spectrum. So this picture is an electromagnetic spectrum arranged in the increasing order of frequency from left to right, or decreasing order of wavelength from left to right, or increasing order of wavelength from right to left, or decreasing order of frequency from right to left. This is because the wavelength and frequency, they are inversely related. So the wavelength is the distance between two consecutive crest or consecutive trough of an electromagnetic radiation. So that is the wavelength. Whereas the frequency is the number of wavelength units passing through a particular point per second. So if the wavelength of an electromagnetic radiation is higher, that means its frequency will be lower. If the wavelength of an electromagnetic radiation is smaller, its frequency will be higher. So they have an inverse relation. And frequency, if the frequency of an electromagnetic radiation is high, that means that radiation has higher energy. So if you arrange electromagnetic radiation based on their increasing or decreasing mode of frequency or wavelength, whatever, so that is known as electromagnetic spectrum. So in this image, if you start from left to right, on the left hand side, left extreme side, you can see the radio waves. So the radio waves have longest wavelength and has shortest frequency or smaller frequency. So from radio waves, if the frequency is increasing or the wavelength is decreasing, then comes the microwaves, followed by the infrared, visible light, ultraviolet, X-rays, gamma rays. So from left to right, you can see the wavelength is decreasing or the frequency is increasing. Okay, so the gamma rays, which comes at the right extreme, has the lowest wavelength among these electromagnetic radiations, and it has the highest energy or highest frequency. So if you think about what are the properties of electromagnetic radiations. So electromagnetic radiations, they show wave particle dual nature. So an electromagnetic radiation has wave nature as well as particle nature, and they consist of oscillating electric and magnetic field vectors at right angles to each other and at right angles to the direction of propagation of the wave. They can travel through vacuum. They travel at the speed of light in vacuum, that is c equal to 3 into 10 to the power of 8 meter per second. They obey the wave equation c equal to lambda into nu, where nu is the frequency, lambda is the wavelength of radiation. They may be arranged in an electromagnetic spectrum in terms of increasing frequency and include radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. So next comes the spectroscopy. So spectroscopy is the study of the properties of matter through its interaction with different frequency components of the electromagnetic spectrum. So that is spectroscopy. So that means if you take a matter and if you study how that matter is interacting with the electromagnetic radiation. So electromagnetic radiation contains a magnetic component as well as electric component. So how this matter is interacting with either of these, either with the magnetic component or with the electric component of an electromagnetic radiation, that study is known as spectroscopy. So this picture is a diagrammatic sketch which represents what is spectroscopy. So in spectroscopy, so our sample is placed here. The compound whose interaction with the electromagnetic radiation which we want to analyze is placed here, and there will be an emitter to emit electromagnetic radiation of appropriate wavelength or frequency depending on the technique we use. So that electromagnetic radiation comes an incident on our sample or matter. So the matter or matter will be compound will interact with the electromagnetic radiation. So the emitted radiation is analyzed by a spectrometer which gives us the result. So from the result we will get an idea about the properties of the compound under investigation. So this is a brief outline how spectroscopy works. So spectroscopy is a general methodology that can be adapted in many ways to extract the information we need. For example, energies of electronic, vibrational, rotational states, structure and symmetry of molecules, dynamic information. A lot of information we can generate based on the interaction of matter with electromagnetic radiation. So based on what kind of electromagnetic radiation we are using to analyze the matter, there are different kinds of spectroscopic techniques available. So some of the common spectroscopic techniques we are adopting. One of them is infrared spectroscopy. So infrared spectroscopy employs the use of infrared radiations. So the radiations whose wavelength or frequency falls in the range of infrared region. So those radiations we use to analyze the interaction with the matter. So that spectroscopy is known as infrared or IR spectroscopy. Also, it is known as vibrational spectroscopy. Another one is microwave or rotational spectroscopy. So this spectroscopy employs the use of radiations, microwave radiations, and the interaction of these radiations with the matter that what we analyze. The third one is UV visible or ultraviolet visible spectroscopy. So definitely we use ultraviolet and visible radiations, and we study the interaction of these radiations with the matter. That comes in the UV visible spectroscopy. Then we have nuclear magnetic resonance spectroscopy, where we use the radio waves along with an external magnetic field and study the interaction of matter with the radio waves in the presence of an external magnetic field. So that comes in nuclear magnetic or NMR spectroscopy. Likewise, there are different kinds of spectroscopic techniques available nowadays. So each spectroscopic techniques gives us an idea of the compound under study. So different aspects of or different properties of matter can be analyzed or interpreted from the result of these spectroscopic techniques. So this diagram represents energy levels in a molecule where E0, E1, E2, this represents the electronic energy levels in a molecule, and each electronic levels you can see V1, V2, V3, V4, V5, those represents the vibrational energy levels, and in each vibrational energy levels you can again see R1, R2, R3, R4. So these represents rotational energy levels. So rotational energy concerns the rotation of the molecule around its center of gravity. So that means a molecule in a ground state will be in the lowest rotational energy level, and that molecule can go to the next rotational energy level if the molecule absorbs a radiation which gives that molecule the energy needed to go to the next higher rotational level. So that energy comes from the microwave region. So a molecule in which there are rotational energy levels, that molecule, when absorbing a particular microwave radiation, it can undergo rotation around its center of gravity. And we can analyze, or we can determine the frequency or wavelength of the radiation absorbed by a molecule to undergo rotational motion. Vibrational energy is associated with the periodic displacement of atoms of the molecule away from its equilibrium position. So that means in ground state, a molecule will be in, or atoms will be in lowest vibrational energy level. For example, here it's V1. So if a molecule absorbed enough energy to go to V2, then that molecule can go to the next vibrational energy level. So normally this energy is obtained from the infrared radiations. So if a molecule absorbs infrared radiation, and by absorbing a particular infrared radiation with a particular frequency or wavelength, that molecule can go from lower vibration level to higher vibration level, so that the periodic displacement of atoms in that molecule will change. And electronic energy is associated with the distribution of electrons of the molecules in its various energy states. So E0 here represents the lowest electronic level, E1 is the next higher electronic level. So if a molecule absorbs enough energy to go from E0 to E1, then by absorbing that energy, electrons can go from lowest energy levels to higher energy level. So this energy normally comes in the range of ultraviolet and visible region, and UV visible spectroscopy is therefore deals with the electronic transition in molecules. So this is a general representation. When a molecule absorbs a particular amount of energy, that molecule goes from the ground state or lower energy level to next higher energy level, whether it's be rotational, vibrational, or electronic. And the another point is, the molecule goes from lower energy level to higher energy level by absorbing a particular amount of energy from a radiation. Okay. And it will emit that energy and goes back to the ground state normally. Okay. So a spectrophotometer either measure the amount of energy absorbed by the molecule. It can also measure the energy emitted by the molecule. So based on this, there are two kinds of spectroscopic techniques. One is known as absorption spectroscopy. The other one is emission spectroscopy. So an absorption spectroscopy is actually measure the amount of radiation, or the intensity of radiation or amount of radiation absorbed by the molecule, and you will get a output, or you will get a graph or whatever the result, and you will get how much amount of radiation with a particular wavelength or frequency is absorbed by that molecule. That is absorption spectroscopy. You can either measure the amount absorbed or the amount transmitted, means the amount of radiation not absorbed by the molecule. You can either represent the result in terms of amount absorbed or amount transmitted. The spectrum will be just reverse in shape. In emission spectroscopy, the detector will measure the amount of radiation emitted by the molecule. So that means when radiation is incident on a molecule, the molecule will absorb the radiation, but the detector is not interested in that radiation. By absorbing radiation, the molecule will go to next energy level, and the molecule will emit the absorbed energy and goes back to the ground state. So that emitted radiation will be detected in emission spectroscopy. So there are two kinds of spectroscopy: absorption spectroscopy and emission spectroscopy. So this is all about the basic principles or introductory part to spectroscopic techniques. So based on this introduction, or based on this principle, nowadays there are different kinds of spectroscopy techniques are available, which will be discussed in later classes. So thank you.